So this is my video on the instrumentation used by the Curiosity rover on Mars. So the Curiosity rover launched on August 26, 2011 on an Atlas V rocket, and it landed almost a year later on August 26th of 2012 in Gale Crater using a crane, or rocket crane as shown here. On the descent, it was using a camera called the MARDI, which is the Mars Descent Imager. What this was doing is it was taking images of the surface of Mars to plan out future routes for the rover to take in Gale Crater. So the famous face of the rover is the head and neck portion, which contains a few instruments. We have the REMS, which is the Rover Environmental Monitoring Station, which is these little pegs that go out of the side of the rover, of the neck. And what this does is it measures atmospheric pressure, temperature, humidity, winds, ultraviolet radiation, several other things too. And then there's the mass cam, which is these two little cameras right here, and what these do is they take pictures of the landscape of Mars and allow the rover to take panoramic pictures for us here back on Earth to just see what it's like to be there. And then the famous eye of the rover is the ChemCam, and kind of the entire head unit as well, which is the chemistry and camera instrument. What this does is it has a laser telescopic camera, and it will look at a rock and fire a laser, and it will measure the elemental composition of the vaporized materials. And this is shown here. It's kind of cool. And then we also have the arm, which has several little components on it. The main bit being the drill bit, which is just a masonry bit at the very end over here. And what this does is it'll use these arm things to lay flat on the ground, get a good drilling surface ready, and it'll drill a pilot hole, and then it will auger and vibrate material up this little shaft and into here, and from there it'll go through the system into the Chimera, which will image it and also take pictures of it and do kind of small stuff, and it will finally transfer over to the main body of the rover, into several different areas. It can go into the Kemen and Sam, and those are actually hidden under the cover over here. And the Kemen is the chemistry and mineralogy unit, and what this does is it will shoot x-rays through the sample and study the mineralogy and composition of it. Obviously it's received from the Chimera through a through kind of dance with the neck called mass transfer, and it'll also go to the SAM, which is a sample analysis at Mars. And what this does is it has a mass spectrometer, gas chromatograph, and tunable laser spectrometer. And what these will do is it will separate the gases, and it'll measure for any materials that are necessary for life, like nitrogen, phosphorus, sulfur, oxygen, and carbon. And then there's also the tunable laser spectrometer, which detects water vapor in the surface, and also allows us to understand like the atmospheres, past atmospheres of Mars. What it also has is little boxes on the sides up here, which are used by the SAM to compare what might be like a false negative to real organic material, and what it does is it just calibrates the system to make sure that it's working correctly. And there's also a picture of the entire same unit. It's like as big as a microwave. To put that in perspective, it's about 88 pounds too. And we also see that there's these two bits which are for the drill. If anything happens to it, they're able to hot swap them out. That actually, I don't think it has been done yet, switching out the drills on the Rover, as it hasn't been needed to be done. And there's also a little observation tray right here to be used by the cameras on the arm, as there is the Molly, which is a microscopic lens on the arm itself, and also the APXS, which is an alpha particle X-ray spectrometer, and just measures the amounts of chemicals that are in samples taken from Mars. And also the Molly is what takes the very famous images of the rover itself. It's like a giant selfie cam, and just takes tons of little images and stitches them together to create the image we see here. And then also all this needs to have a power supply, which is this big hump on the back, which is the MMRTG, which is a multi-mission radioisotope thermoelectric generator. And what this does is it takes uranium-238 and uses the heat generated from the radioactive decay and turns that into power that can be used for the rover. And it's actually quite a bit of power, and it has been used several times on past missions like Pioneer, Voyager, Galileo, Cassini, New Horizons, and this is chosen because, as shown by previous rovers on Mars, solar panels don't work very well, as they can get covered in dust, and there's not really much to clean off the dust, even though there are actually little twisters that can dust off the surfaces every once in a while, but that's very rare. And it's also a lot larger of a rover than any of the past ones we have sent to Mars. It's actually the size of an SUV. It's really big, and they need to have a lot of power to move it safely, and also it extends the lifetime of the mission, as they don't have to rely on having constant sunlight, as there are dust storms frequently on the surface of Mars. And it's also kind of an abundant material, as or at least to NASA, as uranium-238 is created by the production of uranium-239, which is weapons-grade materials, which has an output of uranium-237, which is then radiated into 238, which is a very usable and safe material that is used on that has tons of applications, especially in space exploration. And that is my presentation. Thank you.